friends, this is Dr. Siva Nagaraju from IARE. Today we are going to discuss noise analysis in DSB system. It's double sideband surface carrier system. So how this noise analysis is going on in this system. Okay. So coming to the topic, to judge the performance of a DSB system, we shall calculate its noise. So you shall calculate its figure of merit, gamma, which is given by gamma, which is equal to S naught N naught by Si N naught. So here S naught N naught is the output signal and noise power respectively, whereas Si N naught are the input signal and noise power respectively. Okay, so here our aim is to calculate the figure of merit. So how much this figure of merit is coming from this DSB system. Okay, so for that what we require, we are taking as our S of t, the modulated signal, DSB SC. Okay, so coming to this, we take a block diagram, that is S of t, which is given to the summation and band pass filter, product modulator, low pass filter. So this is the what S of t, that is nothing but our DSB SC signal which is coming, and the noise which is going to add some. So this is the receiver structure, and the band pass filter which allows certain band of frequencies, and the output of this band pass filter is V1 of t, and now it applied to the product modulator as one input, and another input is a carrier C of t, which is generated in the local oscillator, and the output of this product modulator is known as V2 of t, which is again to the low pass filter, and finally we get the D of t. Okay, now we are see one by one. So the first S of t, that is as DSB SC of t, which is nothing but AC M of t cos 2 pi FCT. Already we know that how to generate a DSB signal. Just we are going to apply product modulator, the M of t and C of t, that we get. Now the average power of DSB SC wave is S, which is equal to AC M of t by root 2 whole square. So here you get AC square P by 2. Why? Because the PC, the carrier power, we know this PC is AC square RMS by R. This is the carrier power. But you know AC square RMS we can write as AC square by root 2. So we get substitute, we get this one. So the power PS, which is equal to AC square P. P is M of t. M of t power is P, you can mass, and finally you get PS equal to AC square P by 2. And the average power of noise in the message bandwidth is Pn, which is equal to Wn naught. Here the receiver which takes the input from the channel. So that's why here we are taken as the channel SN0. Okay, so SN0 C indicates the channel DSB. So in the channel we are taking the average noise power in the message bandwidth is Wn naught. So finally SN0 C DSB SC, which is AC square P by 2, which you get the signal power output in the previous one, and a PN is W by NR. Already know SNR is signal to noise ratio. The numerator is the signal and the denominator is the noise. Now assume that band pass noise is mixed with the DSB SC modulated wave in channel. This combination is applied as one of the input to the product modulator. So already we see that V1 of t, which is equal to S of t plus N of t, or N of t is this narrowband noise which adds. So here N of t you can write as Ni of t cos 2 pi fct minus Nq of t sin 2 pi fct. It is in phase and quadrature noise components which the narrowband noise had. So this V1 of t, which you can written as AC M of t plus Ni of t cos 2 pi fct minus Nq of t sin 2 pi fct. Why? Here they taken come an AC M of t having cos term and this Ni of t cos term taken common those two terms. So that's why AC M of t plus Ni of t into the cos 2 pi fct minus Nq of t sin 2 pi fct. So that's the scheme. Now the output of the product modulator is we are going to giving some carrier signal to this V1 of t. So there is cos 2 pi fct. Once again, we go to see this block diagram. So here V1 of t is one input to the product modulator, and C of t is this carrier cos 2 pi fct. So this V1 of t, which is going to multiply with this cos 2 pi fct. So again come back. Yeah. So here the V2 of t, which is equal to V1 of t into cos 2 pi fct, cos 2 pi fct. So already we having custom. In V1 of t, we having custom is there, again sin term is there. So when two customs, which is going to multiply, we get cos square theta. So here we're using cos square theta formula. And again, in the second term, having sin theta into cos theta. It's nothing but sin 2 theta. And again, this term cos square theta, we change it as cos 2 theta, which is equal to 2 cos square theta minus 1. And rearranging, we get that is 1 plus cos 4 pi fct. That means here you can write cos square theta, which is equal to 1 plus cos 2 theta divided by 2 in this form in the first term. Again, second term you can write as sin theta cos theta, which is equal to sin 2 theta by 2. So in this way we are going to rearranging this V2 of t. So that's why here we get V2 of t, which is equal to AC M of t plus Ni of t into 1 plus cos 4 pi fct by 2 minus Nq of t sin 4 pi fct. Okay, now this is the output of the product modulator. This V2 of t, which is going to apply to the LPF low pass filter. So the output of low pass filter is D of t, which is equal to AC M of t plus Ni of t. So our concentration is message signal, not that noise. So the average power of the demodered signal is here, that is AC into M of t divided by 2 root 2. Already know AC by root 2 is coming, and in the denominator already having 2. So when you get square, 2 square is 4, in denominator 4 into 2 get 8, and AC square and M of t, which gives P. So from M square of t, that is written as P, power of the message signal. Now the average power of noise at the output is Pn naught, which is equal to Wn naught by 4. So SNR output of DSB SE system we get as PS naught by PN naught. So PS naught, what is the output of the low pass filter, we can write as S squared P by 8 divided by W N naught by 4. So again you get S squared P by 2W N naught. So this is the output. Now we are going to substitute this channel SNR and output SNR in the manner equation figure of merit, that is gamma, which is equal to SNR output ASBSC divided by SNR channel ASBSC. The figure of merit gets 1. That means the figure of merit of ASB signal is 1. So this is our conclusion to get the ASB SC signal. So this is the noise analysis in the ASB SC system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.